Hello, my name is Craig Voss, and I'm a product manager here at Makino. Today we are filming from our EC Center in Mason, Ohio. Before we get started on today's event, I'd just like to talk through a couple items of housekeeping. Primarily, we want to discuss if you have any questions during this presentation, feel free to enter them in the chat. It's in your upper right on your screen. So at the end of this presentation, I'll take the questions, I'll answer your questions, and we can get those taken care of that way. So with that, I want to jump into the topics for today. Let's see what we're going to talk about. First of all, we want to introduce our Slim Series machines. There's a couple different versions here that have been out for some time now, with the Slim5 being the newest, but we're going to go through the kinematics, the design, some of the construction aspects of these machines. Next, we're going to talk about the Slim5 specifically. This is the newer machine in the line of machines, so we will look at some of those configurations and different highlights of that equipment. And then finally, we want to go through some live cutting demonstrations. We've got some good video of different footage for milling, drilling, tapping. We're going to be looking at both aluminum and steel. So the idea here is we want to, by the end of the presentation, we want you to fully understand that the Slim Series machines are designed not only to be drill tap machining centers, but also to be capable milling machines that can handle a complete part type production scenario. So let's talk about the Slim. What is a Slim Series machine? First of all, it is a vertical machining center. Next, 3-axis. And we have a standard table or an APC version of this machine. So in either configuration, the smaller Slim3 or the Slim5n, we can do both that standard table machine, or if you'd like to be able to load, unload while you are processing the part, with the spindle, we can offer that APC. So that becomes a more efficient type of very basic automation, if you will. And we also have some optional 5-axis configurations, 4 and 5-axis. So we can talk about that a little bit, those tables and what we have available. Now let's jump in with the kinematics of this machine. If you see here, you can see how we've got the X, Y, and Z axis. This is a stacked axis type design. So all those axes are located up high on the machine, away from the chips and the coolant, very much protected. And, looking toward longevity there and lack of, limited maintenance required. So this configuration is also ideal for automation. It facilitates part loading, as you'll see as we get into some of the additional information on the machine. And finally, the base version of this machine comes with a stationary table. So what you're going to see is the front area of this machine. We can basically bolt on several different options. That base option being this standard table, which is shown here. It's a compact, it's a narrow footprint. Because of the stacked axis design, we maintain a narrow footprint on the machine. And that allows us in this table version, since we don't have to move that part around, to have a relatively high payload, given the size and the footprint of this machine. Now let's look at some basic specifications. I'm not going to go through all these numbers, but as you can see, we've got some similarities when we look at Y-axis and Z-axis. As I mentioned, with the stacked axis design, these machines are very narrow. We're not moving the table around. So because it stays stationary and we bring the spindle to the part, we're able to come up with a very narrow footprint. So you see, in the case of the Slim3n, we're 4.2 feet wide. In the case of the Slim5n, we're going to be 4.9 feet wide. The primary difference when we look at, the movement from the Slim3 to the Slim5 is going to be in that X-axis. So you notice you have considerably more X travel, 710 millimeters to be exact there. And what that does, obviously, it increases the width of the machine, but as you can see, the depth of the machine remains the same in either case. Now let's talk about some of the design aspects, some of the goals of this Slim series of machines. So the primary goals when the machine was developed to develop a drill tap machine that's also capable of milling. And that is kind of the key point that we want to look at. We want to keep reminding ourselves of here. And with that milling capability, we want to have extended perishable tool life. So there's certain design aspects that help us with these causes, and listed here are a few that we're going to talk about in some detail. So first, we have the solid cast base. This is the foundation of any Makino machine. We want to talk about that casting and the different aspects that make this a very rigid design. Next, we're going to talk about some of the components that are bolted onto that casting, namely the oversized linear guides. We're also going to talk about ball screws, motors, and how those may differ from some of the competition that's out there. And then finally, a very key aspect to this machine and somewhat unique in the marketplace is the spindle taper. We have an HSK A50 taper on the spindle. This allows for a lot of the milling capability and rigidity that we're going to see in this platform of machines. So let's talk a little bit about the construction. We have a one-piece column and bed on this machine. That's going to offer us some enhanced stiffness, very good rigidity, and damping of those cutting forces. We also, with this design, are able to maintain the agility and the speed required for small parts. So there's no compromises here. Although we have this heavy structure, because we don't move the table and the part, we simply move the XYZ axis and bring the spindle to the part. We have a very agile machine, very quick with extremely high acceleration rates, as you'll see later. And then the key point with the table being fixed, as we mentioned, the axis dynamics do not change. So depending on the fixture size, the part weight, we're going to see a consistent motion and speed because none of the upper axis travels change. Our stacked axis design, or XYZ, they're able to move to the part very efficiently. That doesn't change whether we run small parts or whether we have larger parts on that table and utilize the full payload capacity. Key point here, the machine weight. These are small, machines that are in some of that drill tap machine type category, but this machine weighs, in the case of the Slim3, we're just at 10,000 pounds. In the case of the Slim5n, we are close to 12,000 pounds. So very significant mass of iron there. This is what allows some of those agile movements, the increased deck rates, because we have the stability built into the base of that machine. Now let's talk a little bit more about some of the other construction aspects. So we've got a cross slide type moving axes. The ball screws and linear guides, as I mentioned, they're away from the chips, the coolant, all of that remains down below. So we've got all of those components up high, out of harm's way. Next, let's talk about the spindle overhang. So when you look at the design of this machine, we have a very small distance in that cross slide up top. So where we have our x-axis motion, the spindle is relatively close to that support that ties in with our base casting and machine. Now, previously I mentioned we were also going to talk about the components that mount to the casting of this machine. So we want to talk about several aspects. Obviously, the linear motion guides, the ball screws, and the axis motors. As you can see in the chart here, we're comparing ourselves to a drill tap machine competitor in the market. When you look at the diameters for ball screws, the size of the linear guides, and the kilowatts, the power of those motors, in all cases, the Slim3 and Slim5n have a higher value there. They've got larger components, bigger power on the motors. And again, these are some of the things that allow us the milling capability that we're going to demonstrate today. What this does for you, the customer, so it enhances the axis rigidity. Obviously, these components, they're actually similar to some of the sizes you would see on some very small horizontal machines in some cases. So it's going to enhance our axis rigidity. that will support the milling operations that we're going to show and that we've been targeting with this machine series. And then finally, all of this will result in sustained mechanical accuracy that allows you to make good parts day after day after day, day in, day out, in a high volume type production environment. So the benefit to you, the customer, we're going to see improved tool life because of this type of construction. We're also going to see quality parts. The two things that will add to your bottom line, that will, create a winning solution for you, the customer. Now let's talk about the spindle taper. We mentioned this earlier. So HSK A50 is a standard on the Slim series machines. This aspect is very critical to what we're looking at here with milling. When we compare to the standard BT or CAT 30 type interface, there's several things we want to look at. So with connection rigidity, with a BT or a CAT interface, you have a single face of contact on that taper, as we've shown above here. When you look at the HSK, we move to the two-face scenario where we have taper contact as well as face contact. Now, when we look at tool change repeatability, on the BT CAT side, because of just that taper location and single face location, we have some average repeatability for tool change. When we look at HSK, we have a very good solution there for tool change repeatability. We're going to put that spindle back, or put that tool rather back in the spindle very effectively and precisely every time it enters the spindle. When we look at high speed applications, the BT or CAT interface, there's some compromises with that, and actually at a point where it simply will not work with high speed spindles because the spindle mouth wants to open up, the tool wants to retract further into that spindle because of the inertia there. That can cause changes in your gauge length that are unwanted, and frankly, ultimately it could cause tools stuck in the spindle. So when we talk the higher elevated RPMs, the HSK is a superior connection for that. Again, because this two-face or two surface contact that we have there, primarily that face contact, which keeps that tool in the proper gauge length position at all elevated speeds. And then finally, we want to look at run out. As we've kind of mentioned it with some of these other categories, the HSK interface has much better run out properties than a BT or a CAT type system. So when you look at your precision for your parts, concentricity on bores and features on a part, the HSK will most always be a better solution. So overall, to summarize, the HSK in all these categories we've talked about is a superior interface. And as we're going to show as we move along, it allows us the capabilities to do some things that you just would not be able to do with a 30 taper type interface. So let's look at the benefits of this flange contact, some of the other benefits we want to talk about. So less resonance, we're going to see less chatter effect because of the rigidity of that connection. Much better scenario there. Less deflection. So again, that rigid setup allows us to maintain that tool tip even at extended length tools with very minimal deflection. Also less run out, as we mentioned. So we previously mentioned the run out being a best case scenario with HSK. That's what this chart does a great job of showing. And finally, what that leads to is improved tool life for you, the customer. So when we look at the chart specifically, what we see is when we're talking about a BT or a CAT type tool, there's a limit to the run out that can be achieved there. And at the point where we use an HSK, we transition into another scenario where we can get much improved run out, and we can bring you into a whole nother range of run out scenarios. That directly impacts your tool life, which we've shown here on the left. So that is the key point here, is with this system, we're going to get better tool life all around, as well as all of these improvements in quality and accuracy. Now let's talk a little bit more about the deflection and what this HSK taper does for us. We've got a quick video here kind of showing the clamping scenario with BT shank. So again, we talked about the rigidity. It's only single face. not as good repeatability. When we go to the HSK, we're going to clamp inside that flange and also have the face connection. So very good tool change repeatability and high security. At the end of the day, the key point I would think is this HSK A50. We've got 1.97 effective diameter where that tool is mounted. In the case of the BT30, we would have 1.26 inches of effective diameter there. So because that diameter is increased, it actually has a very drastic impact on deflection. It's 12 times. So you're going to see deflection minimized by 12 times because of that face contact on the HSK 50 tool. Now let's talk about some of the variants of the Slim5 machine in particular. This basically parallels the Slim3n, but today we're going to focus a little more on the Slim5 since it's newer to the market. We want to talk about the different types or configurations of machines you can purchase. So the fixed table version, what we're showing here, is the most basic form, as I mentioned earlier, includes an 800 by 400 millimeter table on the machine. It does include rotary table support. So as I also mentioned earlier, we can add a fourth or possibly a fifth axis to this table if that's what's required for your part and we have sufficient space on the machine. And then finally, we have fixture hydraulic and air, as well as an interface, which we're able to, which we supply standard on this machine. And that allows you to connect your hydraulic fixturing. You can use air for fixturing or part seat detect, depending on the type of fixturing required for your part. Next, from the table machine, we want to talk about the APC version. I briefly mentioned this. So in this case, again, on the front of the machine in place of the table, we're going to bolt this mechanism you see here in the center. That's our servo-driven APC unit. Again, we can also support rotary tables on this pallet changer. So we can go with a couple different configurations. We can put a fourth axis on both sides of this pallet changer, or we can go with a single 5-axis table on one side or the other. So depending on your needs, we can set you up for multiple operations and multiple part types if desired. And then again, just as was the case with the table machine, we also have fixture hydraulics and air. So we have those available right at the table on each side. So we've got some porting in that tool changer barrier there behind the pallet where we can plug lines in. We can feed your fixture for your part for all different types of scenarios. Now, the final configuration we want to talk about is the Slim5 4+1. So this is a scenario where you need a dedicated 5-axis machine. Again, we have this bolt-on unit that includes our trunnion axis as well as our full rotary axis. So we have an A-axis tilting axis, which is mounted directly to the bed, as you see in that center view. This is a dual drive system with hydraulic clamping on both sides. So we can rigidly clamp your fixture and your part in position once we have it in the proper location. We have the full C-axis rotary axis in that cradle type table scenario. And what this all does, this design provides a very large work area. There's ideal chip flow because we have no stationary table below any of this. There's limited area for chips to become trapped or pile up. So what you're going to find is very effective chip evacuation and flow. And then finally, as with all of our Slim offerings, we do offer the hydraulics and air again as standard. We have 5 lines included with a rotary joint, and all of that comes right out the center of the pallet. So we can easily connect to that with your given fixturing for any application. Now, continuing with the Slim5, I want to talk about some things that are a bit different from the Slim3. So the Slim3n, as we mentioned earlier, was the first machine in this line of machines. The Slim5n came later. We officially released this to the market at IMTS in 2024. So almost a couple years ago now. Some of the additions and changes from the Slim3, obviously the machine's a bigger machine, so we have larger strokes, 45% more in the x-axis. We also have a larger work envelope, so more space for maybe larger parts or multiple parts on a given machine. Payload is also up by 50%. And with all of this, there's a very minimal increase in floor space to gain this. So only 16% larger. As we mentioned, because of that axis configuration and the fact that we're not moving the table at all, that allows us to maintain that small footprint even when we expand the strokes. The next thing we want to talk about is improved productivity. So that's in the way of the rapid traverse rates in X and Z axis. So this is improved over the Slim3. We're now at 60 meters a minute. And what's basically happened there is with this very rigid, larger, heavier structure, we're able to move a little faster. We can accelerate and decelerate at much quicker rates, and that results in that quicker rapid time. Finally, the last thing we want to talk about is the superior thermal stability. So both Slim3n and Slim5n contain jacket cooling on the spindle. However, the Slim5n is taking things a little further with also some additional cooling on the the Y and Z axis. With that, we're gonna cool some of the support bearings, ball nut flange, and motor plate type cooling, and we'll show you what impact that has in some slides that we're going to get to here in a minute. Now let's talk about the table design. So the payload for the Slim5n is 600 kilograms. That's 200 kilograms more than the Slim3. So quite a bit more payload given them, just the increase only in x-axis. Now, when we look at the overall stiffness, I think I mentioned that with a little heavier machine, we're able to improve the stiffness over the Slim3n, and that is what's allowing for this much larger payload. So you can see in all three directions, we have a very significant increase on the order of 80% in difference in stiffness in those directions. Okay, let's talk. We mentioned the machine travels and specifically the rapid rates. So in x-axis, we have improved the rapid rate. We're at 60 meters a minute. What does that mean for you, the customer? The charts below are showing that we are basically 17% faster for 500 millimeter distance. So pretty significant increase there. Also note that our acceleration is 1.3 G. When we look at the Z-axis, similarly, we have 60 meters per minute. We're 15% faster over a 400 millimeter distance there than the previous Slim3n. And in this case, we're at 1.5 G. So pretty impressive numbers for a machine of this size. Again, we're relying on that core casting design to support the ability to achieve these speeds and these rapid rates. Part of what's allowing us to do this is that higher servo velocity gained. So without that structure, we would not be able to make these moves. And I guess one other thing I'd like to note here is that with these machines, we do require a pretty substantial foundation. And that's something that all of our customers need to be aware of. In order to achieve this type of performance, we need to have the proper foundation under the machine. So if you do become interested in a machine like this, I'd encourage you to reach out to your sales representative. They can connect you to myself, the product manager, or any of our technical experts here who can help you out with that foundation and make sure you're aware of what needs to be, what we need to support that machine from a flooring perspective. Now let's talk about the thermal control. So Z-axis in particular, we have built-in cooling channels on the motor and the adapter. So what we're seeing some differences here when we look at no cooling on the left, cooling on the right. You can see in this lower area the improvement, but we're not seeing that creep of that thermal, that heat, migrating into the rest of the machine. Ultimately, what this means, we've reduced the temperature of the motor winding by 10 degrees C. That's 10%. And we've reduced the temperature of the motor bracket by 25 degrees C. So that's 46% reduction. So obviously here, we're looking at that thermal control to maintain the stability of the machine and also the accuracy of the machine. And another thing that does, it improves the duty cycle. So we're able to run at a higher duty cycle when we have that thermal stability and we don't have to wait for that heat to dissipate. Now, when we look at the y-axis, some similar things going on here. We've got cooling channels on the bearing housing and the ball screw nut. Again, we've got significant reductions in temperature. The bearing is reduced by 10 degrees C. That's 25% reduction. And the ball screw nut temperature is reduced by 5 degrees C, so 14%. So again, we're preventing that heat from affecting the rest of the machine. We're keeping it localized, and we're basically maintaining the rest of the machine at a more constant temperature. This is going to improve your bearing life. It's also going to promote that thermal stability that provides the higher accuracy we're looking for. So now, look, we've talked about the Slim5n. We've reviewed the different types of configurations available for the machine. We've talked about the design aspects, the kinematics. We want to get more into the machining capability of this platform. So the demonstration we're going to show first is intended to show a variety of different types of machining in a billet aluminum block. The idea here is to convey that while this is definitely an agile drilling and tapping machine, we're also able to mill and aggressively remove material for roughing type operations due to the rigidity and the power of this machine. So the following example, we're going to see several different tools included here. We have a 1-inch inserted drill. There's also a 3/4 inch end mill that's doing some side milling. And we've also got a 3-inch face mill, among other tools. So there's several other tools you also see run here. We've got some small clips of each of those in action. So with that, we want to kind of jump into this video and we'll show you what that looks like. So first is the 1-inch drill that you're going to see there. This is quite a bit of metal removal. A through hole followed by 2 pockets. The 2 pockets are later enlarged with an end mill. We're using that to rough out the material. This is the 3/4 inch end mill. And what we're seeing here, we're using some dynamic milling paths, allowing us to maximize the metal removal rate with the given power here. So this combined with a spindle that has very good continuous power, these dynamic milling paths can really maximize the amount of metal you can remove for a given horsepower. So with us having a little bit higher horsepower capability than maybe some other options on the market, this can be very effective. So now that you have an idea of what's possible on the Slim series machines, particularly the Slim5n, we want to look at the 2 different types of spindles, and we want to detail kind of what's possible with different types of cutters, different applications, and give you some details, some numbers on what types of metal removal rates we're able to achieve here. So first off, I want to talk about the 16,000 RPM spindle. General characteristics here: this spindle is capable of 50 to 16,000 RPM. It's HSK A50, as we mentioned. It is a grease pack spindle. Bearing size is 55 millimeters, so a rather large bearing pack in there allows us the rigidity that compares to that HSK 50 interface. Act deck times, very impressive at 0.7 seconds for act deck from 0 to full RPM. And when we look at the curves, so we want to talk about both power and the torque. As you can see here, our continuous power, very impressive at 15 horsepower continuous. So in addition to the 15 horsepower continuous, we can reach 20 horsepower max in a duty rated type scenario. As far as torque goes, we're at 14 foot-pounds continuous, 27 foot-pounds max. This first example is a 63 millimeter face mill in aluminum. So a couple of key points as you watch this video. Again, this is the 16K spindle. We are machining in 6061 aluminum with a 63 millimeter face mill. We're at a 50 millimeter width of cut and an 8 millimeter depth of cut at 1420 meters per minute. All of this results in a metal removal rate of 1200 cubic centimeters per minute or 73 cubic inches per minute. For the next example, we will see a 25 millimeter inserted drill in aluminum. As you watch the video, remember this is a 16K spindle again. Once again, we are machining 6061 aluminum and using a 25 millimeter inserted drill. We're machining both through and blind holes in this scenario at 275 meters per minute. The resultant metal removal rate here is 387 cubic centimeters per minute or 25 cubic inches per minute. So we've seen a couple examples of machining aluminum with the 16,000 RPM spindle. Next, I want to take a look at some steel machining and show you what's possible in those scenarios. In this case, we'll be looking at a 63 millimeter face mill in steel. Similar to the first two videos, we are again looking at the 16,000 RPM spindle. We are machining 1045 medium carbon steel and using a 63 millimeter face mill. The width of cut in this example is 38 millimeters with 3 millimeters depth of cut. The machining speed is 300 meters per minute. Effective material removal rate is 105 cubic centimeters per minute or 6.4 cubic inches per minute. Now let's see another example in steel. This is a 30 millimeter inserted drill. Here we are using the standard 16K spindle, machining 1045 medium carbon steel with a 30 millimeter inserted drill. Cutting speed is 188 meters per minute, and the metal removal rate is 85 cubic centimeters per minute or 5.2 cubic inches per minute. So that completes the cutting demonstrations for the standard 16,000 RPM spindle. Next, we want to take a look at the optional spindle for both Slim3n and Slim5n, which is the 8,000 RPM spindle. Some of the characteristics here are RPM from 50 to 8,000 RPM. Again, we're using the HSK A50 interface. This is a grease pack spindle. And again, the same size 55 millimeter bearings. 0.4 second act deck time in this case. So you'll realize that's quite a bit faster than the standard spindle, reason being the additional torque we have available with this spindle. Now let's look at the actual curves. So when we look at power, again, we have a very respectable continuous power level of 15 horsepower. That's the same as our standard 16K spindle. When we look at the max horsepower, we can go to 25 horsepower max. So that is a bit elevated from what we have available on that standard spindle. When we look at torque, these are the numbers to really pay attention to, and this is really the purpose for this spindle. 24 foot-pounds continuous and 59 foot-pounds max. So that's a considerable increase over the standard spindle on the order of 2 times. Now let's look at some cutting examples for this spindle. For the first example, we have a 63 millimeter face mill in steel. Remember, we are now viewing the 8,000 RPM spindle. This is machining 1045 medium carbon steel with a 63 millimeter face mill. The width of cut is 50 millimeters and depth of cut is 3 millimeters. Cutting speed is 240 meters per minute, and the metal removal rate is 150 cubic centimeters per minute, or 9.2 cubic inches per minute. Our next example for the 8,000 RPM spindle is a 40 millimeter inserted drill in steel. Remember, we're cutting with the 8,000 RPM spindle in 1045 medium carbon steel. This is a 40 millimeter inserted drill running at 185 meters per minute. Material removal rate for this case is 226 cubic centimeters per minute, or 13.8 cubic inches per minute. Our final cutting example for today is an M24 tap in steel. This example again uses the 8K spindle in 1045 medium carbon steel. It's an M24 tap and we're tapping at 30 meters per minute. So in summary, I want to review a couple key points from the presentation. First off, we talked about the Slim Series machines. We talked about these machines being more than just a drill tap machine. So we explored many aspects of the machines. We talked about the fact that these machines are a complete part solution, where we don't need to use them just as a drill tap operation. We can also perform the milling, the roughing, the finishing, and produce complete parts. We talked a little bit about the design and construction aspects that allow these machines to do the heavier milling operations and some of the larger metal removal ops. So the heavy duty components, we talked about linear guides, ball screws, motors, that HSK connection on the spindle. And finally, we showed the cutting capabilities. So what you saw in some of these examples was 70 cubic inches per minute metal removal in aluminum, and 14 cubic inches per minute metal removal in steel. That's all for today. I appreciate your time. We will be hanging on here to answer some of the questions. Thank you.
Good afternoon. First, I want to thank everyone who joined today. Hopefully everyone got something out of this presentation and some of the live cutting demonstrations. We wanted to take a bit of time here to answer some questions that have come in. So let me start with the first one we have here. It says, what does securing of the machine to the floor look like? Is it a 3-point system similar to the horizontals? That's a great question. And short answer is no, it is not a 3-point. a little more detail on that. So with the design of this machine, we're just not able to put it on a simple 3-point location and be able to, properly support that machine. So what we have is a 4-point. In the picture on this question slide here, you can kind of see in the lower right where we secure 2 of those points on the one side of the machine to the floor. So basically, we've got the 4 corners supported, and then we do secure those 4 corners to the floor because of the ACT deck on this machine. Okay, we have another question here. I've not used an APC type machine before. Is there a way to view machining on that machine? So great question there. Yes, it is a little different, and we've got the wrong picture here on this slide, but as with any kind of machining center of this type, we've got the front door, obviously, where you load and unload parts on the pallet changing machine. But then we also have some side doors in that case. So in the case of the Slim3n or the Slim5n, you're going to find a door on either side of the machine that will view into the machining area. So you're able to open that door. You can get in there, for setup work or inspection if need be. Those do open. And like I said, we've got that actually on both sides of the machine in case you're in a situation where you've got a tight fixture and you need to get around to the other side. So we do have some access there. Okay, let's see what else we've got here. With the base being so rigid, does it matter if the machine is perfectly level? So you are correct with a good base of a machine. You may think that, okay, the machine supports itself, being perfectly levels, maybe not the utmost importance. However, based on our evaluation and performance of this, we always want the machine to be level as possible. That's done at initial installation. And basically, if that's done right out of the gate and you're on the proper foundation, you should only have to do that one time. You shouldn't have to repeat that or tweak it at all. The base, really what that base gives you is a foundation that once you have your level established, the machine installed correctly, you're going to have a solid level machine that maintains that and will remain that way. Okay. One more question here, and that is, are other spindle tapers available for this machine? So short answer here is no. A little more detail. Makino feels that, offering a taper other than the HSK A50 would be a compromise in the capability of this machine. And so therefore, there are no other spindle tapers offered on the machine. And I think final question here. What is the required thickness of concrete for the base? So I don't know that exact number off the top of my head, but I can tell you it is in the neighborhood of 10 to 12 inches. So, pretty significant chunk of concrete. And again, the reason being is so that we have the proper support so that we're able to run the full acceleration on this machine. Now, I will also add to that, we have had customers put these machines on lesser foundations. So in those cases, what we will see is we're unable to achieve the performance with the quality we're looking for. And what we're able to do, if there's just no other way around that to get the proper foundation, we can limit the acceleration, deceleration on the machine. We've got some different settings we can use to allow the machine to operate on that, maybe a little bit less floor than we'd like to see under it. Okay, we continue to have more questions coming in here. Another one around the HSK A50. How does that compare to CAP 40? So I don't have a direct comparison in front of me there, but what I would offer in that is that, first off, let's say when we look at an HSK A50 compared to a 30 taper, the clamping force is about double what you see on that 30 taper in the HSK 50. So with the added rigidity, the added capability there, what that does is it pushes us more toward what you would expect out of a Cat 40. So kind of the way I like to explain that is, that if you have an HSK A50, you'll be able to do, it'll become closer in performance to what you'd see from a Cat 40, and obviously much better than what you'd see on a Cat 30. So hopefully that answers the questions here. It looks like we are pretty much wrapped up on that side. I appreciate all the great questions asked. And I encourage anyone that's interested in more information to reach out to us either through the website or contact your local salesman. And we're happy to help. We're happy to look at your applications and work with you on finding a solution for your part. So again, thanks for joining today. I appreciate your time and hope you come back for future events. Thank you.